Hi, everyone. On behalf of Cenosco, it's my pleasure to welcome you to our 22nd Asset Integrity webinar. My name is Ivana. I am the event strategist in Cenosco, and I will be hosting this webinar. Today, we are going to dive into a real FPSO life extension project, and we are pleased to welcome Cenosco's domain expert, Rowan, to this discussion. Rowan is a chartered professional in integrity, materials, and corrosion with over 13 years of technical and leadership experience in the energy industry. Before joining Cenosco, he worked at Blue Water, where he was involved in the FPSO Life Extension project, which we will be discussing today. This gives him a unique perspective, able to speak both from the user side and now from the vendor's point of view. Hi, Rowan. How are you doing?
Hi, Ivana. Thank you. I'm doing great. Happy to be here.
Great. Then I would like to welcome Jocelyn. He is the Operations and Maintenance Director with 20 years in the energy sector, focused on optimizing large-scale offshore oil and gas. Jocelyn is currently working at Blue Water and was also involved in the FPSO project that we will be discussing. Hi, Jocelyn. How are you doing?
Hi, Ivana. Thank you for inviting me to this webinar.
Thank you, Jocelyn. So as we said today in our discussion, Rowan and Jocelyn will share insights from their FPSO Life Extension project. They'll walk us through their approach, highlight what worked well, and reflect on areas for improvement. Following the discussion, we will open the floor for questions. We have already received a few in advance, but please feel free to drop any additional questions in the chat. Lastly, please note, if for any reason you experience a bad connection, a refresh of your browser will normally do the trick. Jocelyn, to start us off, can you tell us a bit more about Blue Water, please?
Yes, of course. So Blue Water has two main core businesses. So the first one is to support the energy transition. And our ambition is to be recognized in the energy sector as an independent, world-class provider of innovative, reliable technology and safe services in the offshore industry. So for that, as you can see on the picture on the left, we are acting as EPCs for buoys and essentially to transfer hydrocarbons or other chemicals from one ship to another or from shore to a ship. So those chemicals include methanol, ethanol, and ammonia. We also design, procure, and manufacture e-buoys, which transfer electricity and signal from the shore to the ship. We also develop floating wind turbine and floating photovoltaic farms, as you can see on the two middle pictures. And finally, we provide green solutions for FPSOs. And then the second core business is to operate FPSOs. So FPSOs stand for Floating Production, Storage, and Offloading Facilities. And Blue Water currently has 5 FPSOs. 3 of them are currently located in the North Sea, and 2 of them in Southeast Asia. We also operate third-party owned FPSOs, where we provide a corporate management system. We provide also experienced and qualified workforce. And finally, Blue Water has 40 years experience in operating FPSOs. So that's very valuable for third-party owner for FPSOs.
Great. Thank you, Jocelyn. Thanks for a very good overview about Blue Water, a very detailed overview and a good, insightful overview with regards to what Blue Water are currently doing in the energy landscape. So, Jocelyn, before we deep dive into our topic of today, the Life Extension Project, maybe I can provide a bit of context with regards to who our typical audiences are. Our typical audiences are experienced professionals from the energy industries, mostly coming from inspection, integrity, reliability, materials and corrosion engineering background, but we do also have young professionals joining in as part of this webinar as well. So let's try to make this session a bit engaging so that it's also useful for someone who's joined the energy industry very recently. They can gain something out of this session, but at the same time, let's also make it enticing for the experienced professional as well. How does it sound?
Very good.
Good. Let's do that. Okay, so before we deep dive into the life extension project, Jocelyn, maybe could you give us an overview with regards to the FPSO that we will be talking about today, the Heavy and Brim FPSO?
Yes, so today we are going to use the Heavy and Brim FPSO as an example. So once again, FPSO stands Floating Production, Storage and Offloading Facility. Heavy and Brim has been operated in the UK continental shelf since 1999. And as you know, this is one of the hardest environment in the planet. And we are operating under the UK safety case, which is also a very strict regulation. So because it's operating in one of the hardest environment, it's fitted with a disconnectable turret. And it's currently producing, it has a production capacity of 75K barrel oil equivalent of gas and oil, and has a storage capacity of 626,000 barrels spread out over 16 cargo oil tanks. So essentially, this is the Heavy and Brim, and so you understand the purpose of an FPSO is to produce oil, water, and gas from the subsea wells, separate them into 3 phases, and then export the oil as is the most valuable component.
Good to know that, Jocelyn. So, just as a background, HB, the Heavy and Brim, started to produce and exporting gas from the recent life extension project in 2021, 2022, if I'm correct. Maybe could you please highlight a bit about the background of the campaign that facilitated the upgrade and the life extension as well, and maybe what are typical activities that were carried out as part of the campaign?
So until 2021, all the gas we were producing were re-injected into the reservoir, maintaining the reservoir pressure. But from 2021, our client told us that there's more value to get out of the gas if it's exported onto the market. So essentially, that was the driver for this campaign, to transform or to convert gas injection into gas export. Also, the client informed us that there may be a strong likelihood that we may produce sand very soon. So as a result, we had to install a sand handling module. And then when you take this decision, which is a very heavy decision to go back to the yard for such a modification, then you take all the opportunities you have to carry out other inspection, other maintenance, and other repairs. So all in all, we had to consider the main driver, but also all the other scopes we had to carry out at the same time.
Okay, good. So maybe to start off with, right? So the activities 1 and 2 that is typically highlighted. So of course, there was a new sand handling module that is kind of fitted in because it was expected that there will be sand produced from the wells. So as a facility, the facility had to deal with the sand that was being produced. And of course, reconfiguration to enable gas export as well. So could you just throw us some light with regards to what were the typical activities that were executed as part of fitting the new sand handling module and the reconfiguration in order to export gas as well?
Sure. If you go to the next slide. So here you can see the module that was fitted. So we call that a pancake module because essentially we are fitting 3 major systems into one module. So on the left, you can see the sand handling module. In the middle, you can see the gas export valve, but also fiscal meter. And then on the right, that's what we had to add, which is essentially made of deluge system and utilities. But it doesn't resume to that. We also had to make major modification to the gas compressor. We had to make major modification to separators. We had to add interconnecting piping and cables. And finally, as you can imagine, we had to modify the logic within the ICSS, which is our integrated control safety system.
Okay. So just for my understanding as well, right? So there was expectations that there could be sand in the system. So in order to deal with the sand, of course, a new sand handling module was fitted in. But of course, with sand, there is a potential threat of erosion with the correct velocities and flow rates as well. So to handle such conditions, modifications were required on specific or existing equipment accordingly as well. Interesting to know. So that appears to be quite a lot of activities that were typically carried out in fitting the new sand handling module, and of course in terms of modifying your existing equipment to handle the sand and of course export gas as well.
Yeah.
Good. Okay. So maybe going forward, let's try to focus a bit more with regards to the life extension scopes, right? So maybe let's try to keep the context relevant to inspection, integrity, maintenance as well. So maybe could you just throw us some light? Let's not just focus on the execution part already. Let's maybe if you could just throw us some light with regards to how these life extension scopes were typically identified, how were they planned, and finally we can look at how was these life extension scopes executed and what were typical follow-up activities as well.
Absolutely. So before we dive into the scope itself and answering those questions, which are really critical, I'd like to go through the amount of data we had to process. So the amount of register we had to go through, the amount of system we had to go through, and I'm sure you'll appreciate the size of the scope. So let's start. I've got a list here. Bear with me. So first of all, we had to go through our MCDR, which is Mechanical Corrosion Damage Report Register, otherwise known as Anomaly Register. We had to go through our DLRs, which is a Defined Life Repair. Essentially, these are temporary repair. Fabric Maintenance, Corrosion Under Installation Register, Small Bore Tubing Register. We also had to go through our CUPS, which stand for Corrosion Under Pipe Support, a Dead Leg Register, a Passive Fire Protection Register. And then we also had to go through our system Maximal, which is our CMMS, Computerized Maintenance Management System. Then we had to go through our RBIs, so risk-based inspection, planning. Then go through our SIMP, which is our Structural Integrity Management Plan, which include RBI and class requirements. We had to go through our life extension register, and finally we had to take into consideration all the equipment we had to mothball or decommission. So I'm sure you can size the amount of work and the amount of data spread out in different systems. And to add to the complexities, those systems are fairly siloed. They don't really talk to each other. So it takes really skilled and competent people to really pull out the full scope.
Yeah, that's a very good point that you addressed there, Jocelyn, right? Because this is something that keeps coming back to us, to Cenosco as well. We do see organizations working with multiple systems where data is typically siloed, data not interacting with each other. So what this means as well is that it takes a lot of manual effort, first of all, to pull information from one place, assess that, hand it over to another place, make the best use out of it, and then eventually make data-driven decisions accordingly as well. So disconnected systems lead to decentralized data, which then affects your capabilities or your ability to make decisions much more proactively as well. And that's why systems like Cenosco, I hope you also agree to that, because Blue Water and Cenosco have done a pilot project together. So using a centralized database that typically allows you to follow the complete integrity life cycle of your equipment, pressure equipment in this context because we are primarily focusing on pressure equipment in this context. So the likes of piping, your vessels, heat exchangers, right from the day it was commissioned to the day it was typically decommissioned and removed, following every single activity across its entire life cycle could be typically tracked from a centralized database as well. I think that could have been a lot more helpful in this context, right?
Absolutely. Having a one-stop shop would have been really good. It would have saved us a lot of time and lots of manpower. Definitely, yes.
Of course. So something that's a very good point that you have addressed. So working with a lot of systems eventually leads to inefficiencies, but of course it takes a lot of effort from your side to bring up that scope or build that scope and eventually propose it to your teams accordingly as well.
Yeah.
Okay, so that's good, Jocelyn. So you gave us a good context with regards to what was the background behind the scope identification part. But of course, the scope that you had identified within your inspection, integrity, and your maintenance teams, 100% of the scopes is executing them in the life extension project phase in the yard is usually not realistic, right? So what was Blue Water's approach in terms of screening the scope and really dealing with a specific scope list that could be achieved within the agreed timescale for the yard period?
Yeah, absolutely. Addressing 100% of the scope identified for the past few years is completely unrealistic. So we had to define a workflow where we would prioritize which activities, which issue we would tackle as a matter of priority. So we established this workflow. Essentially, it's a risk-based workflow where anything that's safety critical would be addressed during the yard. Anything that's required a shutdown will be addressed during the yard. And every must-have will be done during the yard. So once we've risk assessed essentially all the activities spread out in all those registered and all those systems, then we can come up with a scope. And then this scope, we propose it to our shareholders, and then they decide whether to go ahead or not. So all the scopes that are not meeting the minimum criteria to make it to the yard then are fed back to the backlog.
Mm-hmm.
But all the scopes that makes it to the scope for the yard then leads to the next phase, which is to go into more detailed planning.
Mm-hmm.
What it means is we start to think about, do we need scaffold? Do we need rope access?
Mm-hmm.
Do we need isolation? And then all that feeds into a work pack where we define in more detail the scope and all the resources we need to address this particular issue.
Right. Good. That is quite insightful, right? So you had a very robust process. I think some of the flow charts that was used as part of that screening process is also highlighted. So using that robust screening process, you were able to identify really the critical scopes that had to be executed. Any other scope that could be done during normal operations were still parked outside so that they could be done once the FPSO restarted production and operations.
Yeah.
Makes sense. Okay, so I think you provided a very good overview with regards to the scope screening, which is actually a very key element in this process. But once the scope is screened, how did that translate to a plan?
Yes. So once we prioritize those scopes, we put them in the plan. So in this case, that took us 18 months in the making.
Okay.
So going through all the record, prioritizing, having conversation with shareholders. So 18 months. And also procurement is key because we had to face very long lead items. So we need to think about procurement way in advance.
Yeah.
So once this planning process, defining the scope, prioritizing took place, 18 months, then we can move on to the execution phase. In this example, we were really unfortunate to be hit by COVID.
Okay.
So that caused many delays and many issues we never faced before, namely having people in quarantine. We also faced issues with Brexit, people from UK working in Norway. That's another thing with visas. It's really complex to handle. So all in all, probably the project shouldn't have taken so long, but it did. I think the industry standard is around 12 months, maybe less. For us, that was 18 months. But yeah, we had severe issues to face.
Yes, of course. You cannot plan for these kind of activities, right? So COVID took a toll across the entire world. And of course, a project like this, a massive project like this, would have also faced the consequences as part of that as well. But yeah, I think you gave a good overview, right? So the scope screening, prioritization, you touched upon work pack preparation. That I think that is quite key to clearly identify what is the scope that needs to be done, what locations, what is the resources that is actually needed for the scope, what are procurement activities that needs to be carried out. So planning that or executing that well ahead of time was quite critical as well. Good. From this moment on, Justin, let's maybe focus on the execution part. So far, we have looked into the identification, scope screening, and the planning. So from this moment on, let's focus on what was actually done during the life extension project in the yard, right?
Yeah.
So let's probably start with the repair activities. So these are repair scopes that were actually identified prior to the yard stay. So these are known repairs or known defects or known anomalies that eventually needed a repair action to be carried out. So maybe could you just throw us some light with regards to what were some of the repair scopes? Because being involved in the yard myself, there's quite a lot of repair activities that were carried out. It will probably take 2 or 3 webinars to even cover that. But maybe on a high level, if you could provide our audience some context with regards to what were some repair scopes that were carried out, that'll be very much appreciated.
Absolutely. So mostly we identified those repair scope on critical equipment.
Yeah.
And then we came up with, I would say, 2 types of scopes. One was repair and one was inspection.
Mm-hmm.
So first, repair, those critical equipment. So you can see a list here and some pictures. Helideck repair. So we had major corrosion issues on this. Ship side valve overhaul, process piping replacement, produced water flash vessel replacement, topside structure. We had crane overhaul, and then other high critical process valve replacement. So that was based on risks,
Mm-hmm.
and then each scopes were addressed during the yard.
Okay. Maybe I can deep dive into a couple of these scopes, right? I will probably highlight the scopes that involved quite a number of preparations from the engineering side, validation from the engineering aspect as well. So the helideck scope that you highlighted was one key critical scope. There were issues with regards to aggressive corrosion on the aluminium beams that was in contact with the carbon steel support structure. Ideally, there should be an isolation pad in between, but over a period of time, the isolation pad got deteriorated. That resulted in the aluminium coming into contact directly with the carbon steel support, and especially offshore environment, perfect conditions, marine conditions, causing aggressive corrosion to the aluminium beams as well. So I think this was identified during your operations during offshore. And of course, a number of surveys were done to really identify specific locations where corrosion was really aggressive or very severe, because the helideck, if the integrity of the helideck cannot be guaranteed, then that typically is a very, very critical issue for your asset, for the asset as well.
Absolutely. The helideck is part of our performance standard, and this is audited by our independent, competent body every single year. So we must show that the helideck is fully functional and has a good integrity at all times.
Yes, definitely. Good. So in terms of repairs, as you could see in the center left, folks, there was a bolted repair method that was typically incorporated during the yard, and the engineering design limited the contact between aluminium and carbon steel, and where contact was really required, isolations were typically reinstated and things like that. So quite a good effort put forward in terms of repairing the heli deck. Another important or critical scope was the walkway, as you could see on the bottom left. So the walkway extends from the forward to the aft, and the walkway previously was quite rigid, and especially in FPSO in an offshore environment, although it's stationed on the field, but due to the wave conditions, the FPSOs usually typically move as well. So there are some dynamic movement expected. So for example, a walkway being rigid is exposed to dynamic stresses such as hogging, sagging, heave. So there was not much flexibility with regards to the walkway as well. So what it resulted is that the walkway being so rigid allowed stresses to be transferred to the walkway supports, and that showed initial indications as well. So during the yard, we not only repaired the indications that were typically highlighted, but we made the walkway more flexible. So that means that spacings were introduced. Walkway was kind of cut into different sections, and spacing was introduced. So now, with the movement of the FPSO, the walkway was allowed to be a bit flexible and move accordingly as well. So thereby reducing the stresses on the associated supporting structure. Again, all these scopes required a number of several weeks to months with regards to engineering preparations in-house done by Blue Water. In some cases, vendors were also utilized. But of course, these engineering assessments were validated eventually in order to plan and prepare for the repair actions, procurement, and other activities were typically carried out as well. Again, a couple of really high quality repair scopes that were executed in the yard, I would say.
Definitely. Plan. We need to understand where this is coming from. So we do have an integrity management plan. We do have RBIs, and we do have class requirements. So all that together makes our inspection scope, because we know what to inspect at which frequency. Some of those inspections are very intrusive, so that's why we take the opportunity of such a campaign to do those inspections. So if I take the example of vessel inspection, it's fairly easy to inspect it from the outside, but it can be really complicated to inspect vessel from the inside, because those vessels are process vessels. You need to isolate them, and sometimes it's not possible to do that during normal operations. Same for tanks. We know that we must inspect them, but again, for isolation purposes, it's sometimes not possible to inspect them during normal operations. And finally, CUI and PFP. So what we are looking for is breakdown in passive fire protection cover, and when we remove them, also we look underneath to see if there is any corrosions. So all of that, sometimes it's really complicated to do that during normal operations, and that's why we use campaign like this, yard scope, to do this when the plant is completely dead.
Okay. Thank you, Jocelyn. That was a very detailed explanation, I would say. Of course, it might appear the inspection scope was fairly limited, but we can tell from experience, right? At vessel inspections, we covered almost every single primary process vessels, marine vessels as well. And just like what you highlighted, doing an internal inspection sometimes may not be really possible during normal operations. Of course, you can count on non-intrusive inspections, NDT from the outside. But of course, there are restrictions with NDT techniques. There are also restrictions due to the design of these vessels. There could be like a vessel skirt limiting access to certain key locations where the risks are. So ideally, getting into a vessel, performing that visual inspection gives that confirmation, especially for equipment where we don't have enough history or enough confidence with regards to the inspections done in the past as well. So similarly, hull tanks and CUI on pipework, and also PFP on structures as well. And maybe to add a bit more context, Jocelyn, so of course, in this yard campaign with regards to inspection scopes, so some of the inspection techniques that were adopted were conventional NDT, such as ultrasonic thickness measurements. In most cases, visual inspections were carried out, but where possible, we needed wall thicknesses. We were typically counting on conventional NDT, ultrasonic thickness measurements, for crack detections, magnetic particle testing, eddy current, dye penetrant testing, depending upon the materials that we were typically inspecting accordingly as well. Of course, there were heat exchanger bundles that had to be inspected as well. So in some cases, we had to count on iris inspections to get an understanding with regards to the tube bundle conditions as well. So a fairly extensive scope that was typically carried out from an inspection perspective. But of course, Jocelyn, maybe an interesting question to ask, right? So performing an inspection, an extensive scope of inspection activity in the yard is one. What about findings from these inspections? How were these identified and treated? And maybe another question to add on to this is that how did Blue Water ensure that these discovery scopes did not pile up and did not affect your project timelines as well? So that is something that we can probably highlight.
Absolutely. So whenever you inspect, you will find a new scope. You will find things. So that has to be taken into consideration in your project in terms of timeline, in terms of resources, and I would say it's quite significant. So it definitely we must allocate some time and resources to address discovery scope. So as you can see on this slide, there's a few pictures of some coating repair, some laydown area repair, some nozzle repair, and other flanges. So these are all the kind of scopes, discovery scopes you can face when you carry out further inspection during your campaign. So the way we prioritize that is the same way as we prioritize the other scope. It's risk-based. So we assess the consequence of having that failing, essentially. And we assess whether or not we can repair it on the spot. Do we need yard condition to repair it, or can be done during normal operation? Do we have the right isolation in place? Are your isolation good enough? So all those kind of questions. So of course, if it's safety critical, it will be done on the spot because it's our highest priority. But then for anything that's not safety critical or environmental critical, then we need to wait whether or not we extend the yard scope and we address it now, or if it can be done later on during normal operations.
Interesting. That's a very good detailed approach, I would say, much more robust as well, so that you are in control with regards to what you're inspecting and what you're finding, and ensuring that the right actions are typically carried out. And if it's not a priority, then it could be done or be executed as part of regular operations as well. So, yeah, good to know that. And maybe, Justin, just to cover the last bucket, right? So when it comes to life extension projects, we did touch upon repair scopes, inspection scopes, discovery scopes. But what about opportunity scopes in general? Was there anything lined up or planned in with regards to opportunity scope? And how much of those opportunity scope were typically executed in the yard?
So unfortunately, I have to say fabric maintenance is always the activity that comes last. And this is what we call opportunity scope. So if we've got the resources, if we've got the time, then we will address what fabric maintenance requires. But I've been in many projects, and unfortunately, it always comes last. So in this campaign, we were able to address issues such as main deck, process piping vessels, and external hull. So we had some resources allocated for fabric maintenance scope, but then again, with all the issues we had with COVID, with all the rest of it, visa issues, sometimes we had to drop some of the fabric maintenance scope.
Right. Okay. But I presume the fabric maintenance scope was also prioritized based on risk so that you can target the critical ones to start off with. and the lower critical could be done as part of regular operations.
Absolutely. So we do have a fabric maintenance register.
Yeah.
And in the register, it's all ranked by risks.
Good.
Yes. Good. So we tackle the highest risks first, and then most of the time, what's has a lower risk can be done during normal operations.
Exactly. Yeah. A very good structured approach, right? Good. Good. Okay, Jocelyn, thank you so much. Thank you for that insightful discussion about Blue Water's involvement with regards to the life extension project. Maybe to the benefit of the audience, could you provide like a summary on key highlights from this projects and what would be ideal recommendations as well?
Sure. So it's clear that you cannot address 100% um, of your scope. You have to prioritize, and you need to take on board your stakeholders. So you need to make clear what's the top priority, and then need to make the case for it. So you need to show your risk ranking strategy, you need to show your method, and then you can only then propose a scope. So there's a must-have scope. What drives the yard scope, and then there's what we must do as part of our normal inspection or normal repair, and then you've got the opportune scope.
Mm-hmm.
Then again, you need to keep in mind that you will have some discovery scope,
Yeah.
and you must allocate some time and resources for that.
Of course.
So bottom line is you will have more work than time on resources, essentially. That's what I'm trying to say. So that's why you need to be ruthless as to what you prioritize.
Right. Okay. Good. So coming up with the proper scope selection was typically key, then planning and execution. And of course, we cannot be perfect, just like what you highlighted, right? So discovery scopes can be identified, but we have to be ready and prepared to react to it.
Yes, so planning first. So you need to make sure that you've got the resources in place. Procurement can be an issue because we've got long lead items. So you need to prioritize those. And then you also need to keep in mind all the SIMOPs.
Yes.
So you need to have an overall picture as to what's going on the FPSO, because there may be some safety implications. And yes, finally, you cannot be perfect. Something may come up like COVID. Well, hopefully that's never going to happen again. There's unexpected scope. Things happen. So again, yes, you need to be a bit flexible in your processes, and you need to allocate some time to plan for the unexpected things.
Yeah. Very well explained, Jocelyn. Thank you for that insightful summary. And finally, what are typical activities that could have been done differently? So we have highlighted a few key pointers, mostly incorporating technology, right? So in this podcast or webinar, we touched upon a number of topics, right? From preparations to scope screening to planning to executions to discoveries and reacting to those discovery findings, right? So let's approach each of the key elements as part of that workflow. So number one is maybe utilizing technology to better justify work scopes. I think we already touched upon that, right? So Blue Water put in a lot of effort to come up with a list of scope that had to be executed. But of course, to come there, Blue Water put in had to verify or look into a number of registers to really identify where the key issues are. And of course, that needs some effort. Data were siloed, inefficiencies with regards to dealing with manual data as well. So I think a technology can help here in terms of centralizing your information in one place. if we have a centralized inspection or an integrity database, so right from your planning, right from your information with regards to where your critical locations are, right from RBI information, all that information, if it's available in a centralized database, that could have helped a company like Blue Water to make that decision much more quicker as well.
Absolutely. And let's not forget, when you come into the yard, you've got lots of data to process. But
Yeah.
when you come out of the yard, you've got potentially as much data to process as well.
Exactly.
And then those data feed into your processes. I'm thinking about RBI especially.
Exactly.
Where you've got more inspection, you've got more data points, so you get more confident as to what your corrosion mechanisms are.
Exactly.
And then you can update your RBI.
Yep.
So if you've got an integrated solution that can do all of that at once, that saves you huge amount of time and huge amount of resources.
Yes, very good point, right? Like you come out with a lot of data, but you have to incorporate that data to rerun your assessment so that you can plan your future activities based on risks. And usually RBI is the first time when you're onboarding into RBI, might take some effort, but if we have a robust RBI program implemented like Blue Water, updating the results will be much more quicker so that you can gain quick value to time as well, time to value as well. Good point. Of course, then one other key point is probably looking at using technologies in terms of continuous monitoring, right? Because there was a number of scopes that were executed. CUI was one of the key scope. So there are technologies in the market that allows continuous monitoring. So once the installation was stripped, once inspections were carried out, any repair actions in terms of discoveries could be executed, coating repairs, painting, replacement of spools and things like that. But on the back of it, if we had the opportunity to install sensors to monitor moisture or monitor the conditions for CUI, that could potentially could have helped in terms of proactive monitoring in the future and planning your activities accordingly as well. So, of course, every single scope that was proposed to the yard team had to be justified as well. And in terms of such futuristic technologies where continuous monitoring is being deployed, I think coming up with an ROI approach, like because Blue Water had a very strict timeline as well, and life extension for additional 10 years. Mm-hmm. So highlighting that value on how would the operator and ultimately the field owner gain by incorporating new technologies for a course of 10 years, I think that is quite key as well.
Absolutely. You need to make a business case for it. Yeah. Probably, again, you need to prioritize as to what, if I take the example of CUI, which pipe do you want to monitor first? You need to prioritize. You probably can't fit sensors on everywhere.
Exactly.
So that would feed into your business plan.
Of course. Very good point. And finally, right, efficient work execution and reporting. You touched upon inspection work in the yard, Jocelyn. Of course, being involved in the yard, we can tell that hundreds, if not thousands, of inspection reports were being generated by contractors, by in-house inspectors. But of course, the normal work process where an inspector would go out to the field, look at the work scope, perform an inspection, record it in a piece of paper, come back to the desk, draft a report. But if that work process could be improved, if it could be made efficient, there are tablet-based reporting systems. As long as the work scope is loaded out into a tablet, and the inspector can typically carry out or record their inspection findings in the tablet, and when they come back, they can sync the data back into a database or something. So that would have massively helped in terms of work efficiencies. You're not duplicating efforts. And so on. So what are your thoughts on that?
Absolutely great. Also, the benefit is that everyone is using the same template.
Yes.
So then to process the data, it's far easier than either a free writing report or just every contractor is using different templates. Yep. So absolutely, I'm all for it. Again, goes down to the business case.
Of course.
So it goes down to that.
Definitely, definitely. That's a good point that you touched upon, right? Standardization with regards to work processes. So if a consistent template is being used by in-house inspectors, contractors, then the way you report is fairly standardized. But of course, once you start reporting a standardized way, you can make decisions. You can pull that data and make decisions with regards to what needs to be done and things like that as well. Good point, Jocelyn. Thank you for that. And with that, we typically conclude this webinar. We will be opening the floor for questions. We did receive a few questions beforehand itself. So, Jocelyn, if you're okay, let's touch upon a couple of questions. And if people have more questions, we can look to address that, or we can get back to those questions privately to the respective personnel as well.
Sure.
Okay. So one of the first questions that came in through, which was asked by a number of people, is what is your expert opinion about RBI approaches in FPSOs? Could you throw some light on that?
Yes. So we moved to an RBI methodology a few years ago. So like you said earlier, the initial work is quite significant because it requires lots of data. So essentially, you need to gather a root. So a root is made out of lots of components that are subject to the same corrosion mechanism, to the same environment. Then you need to detail what type of material we are facing, the design parameters, the operating parameters, and then you need to define what are the possible corrosion mechanisms. Also, based on your inspection history, you need to define how confident are you with the data you have from your previous inspections. And then you need to come up with some sort of consequences if those corrosion types occur.
Mm-hmm.
And then you came up with a ranking, which gives you essentially your inspection intervals, and then that drives your inspection intervals. So if you think about it, a root is made out of many components, and an FPSO is made out of probably thousands of roots. So you can see the amount of work we need to put into this. And again, when you come out of a yard like this and you come up with lots of data, you need to feed those data back into your system, which increase the confidence most of the time. And then you need to revise your inspection intervals. So the benefit of doing that is the more inspection you do, the more you're confident about the data, and potentially the more you can extend your inspection intervals. But that requires lots of data, lots of resources, and if you don't have an integrated system, that makes things even more complicated.
Exactly. Good points that you raised, right? So if you have an integrated system capturing inspection data, wall thickness data, your trends, your anomalies, your temporary repairs, all that could be used to make decisions in your RBI, right? With regards to probabilities of failure, with regards to confidences. If you have a system that integrates IOWs, you can also look into IOW exceedances and things like that. And you can have a robust RBI as well. So a lot of automation could be done here as well. And some of Cenosco's products typically accommodate that as well. And one key challenge with regards to RBI, Jocelyn, is especially what happens whenever there is limited inspection history, right? Or especially with FPSOs could be deployed on a new field after a certain duration of time. So it means that the FPSO will be exposed to new conditions and so on. So usually those are typical challenges that typically occurs within the FPSO landscape. And even with regards to our example with the life extension project. So prior to life extension project, we did not see a lot of sand into the system. There was minimal to no threat of erosion. But potentially after the life extension project or the PDP project, that we can expect sand in the system, erosion could be a credible threat as well. So one of the approaches that Blue Water typically adopted was typically forecasting that after a certain period of time, we can expect sand in the system and erosion could be considered as a threat. And based on that, we trigger activities accordingly as well. I think that is also quite key in terms of really identifying your actual conditions and making your assessments accordingly as well.
Yes, you made a couple of important points here. Is that if you don't have any data, you also need a system that can either calculate or predict what you expect to have during your next inspection. So if you do that manually, it can be very difficult and time-consuming things to do. And going back to the tablets we talked about early on, if you've got a standard approach of capturing those data, those wall thickness that fits into your integrated system, then the entire work is all streamlined and makes everything much more simple.
Definitely. Well explained, Jocelyn. One more question before we wrap up, if that is okay.
Yeah.
So the second question, for an FPSO life extension, what are typical class requirements? Can you briefly explain the process?
Yes. So class is essentially our insurer. So we insure our FPSOs with the company. But in order to be insured, we need to prove that our tanks and other things are in good conditions. So the class society is imposing us to do some inspection. So for tanks, it's on five-yearly basis, and they must be witnessed by the class society. So there's two things here. So during the yard, every inspection of water ballast tanks or cargo oil tanks were inspected by our class society. But we do have an agreement with them that we, as Blue Water, can inspect on our own without having witness from class society for 50% of the scope.
Mm-hmm.
So this is there's been an agreement between us and class society, and essentially this is how we do our class scope.
Okay, interesting. So you touched upon the work execution part quite well, Jocelyn. What about the involvement of class during the preparation phase, right? Were class involved in terms of reviewing the work scopes? Did they give their approval before the work execution started?
Yes, they are involved all the way.
Yeah.
And again, this is a very strict schedule. They say we need to inspect it on 5-yearly basis. This is not 6 years.
Of course.
We must do it. So we can do it early on, but we can't do it later. So yes, they review the work packs. They make sure that people are competent, and then they review the results, obviously, and they witness the inspections.
Right. Maybe something to add here, Jocelyn. You highlighted like class requirements are quite strict when it comes to time-based intervals, five-yearly intervals for most hull tanks. But I'll have to highlight Blue Water also did quite a lot of efforts in terms of hull RBIs, not for this FPSO, but for another FPSO. Maybe that is probably a topic for the next webinar. So good. Thank you, Jocelyn. Thank you for your time. Really appreciate that.
Thank you for inviting me.
It was a really insightful discussion. Thank you for sharing Blue Water's experience and your personal experience with regards to this project. I found it really nostalgic, revisiting those times. But I presume the audiences would have found it quite useful and insightful as well.
Great.
So for the audiences, we have Jocelyn's and my LinkedIn profile highlighted in your screen. So feel free to add us or contact us if you have any questions. And if you have already put a question in chat, we will get back to you with the respective answer as well. Okay, thank you, Jocelyn. Thank you for your time, and thank you, folks, for joining for today's session.
Thanks a lot. Bye-bye.
Bye-bye.